My name is Gary O'Sullivan. I work with the NSAI, the National Standards Authority of Ireland, and I'm here really to present on the Ventilation Validation Registration Scheme. So back in November of 2019, we had updates to Part L and Part F of the building regulations. There was a transitional period, as there always is, with an update, and these came into effect on the 1st of November 2020 and applied to all new dwellings. So some of the impacts are some of the updates resulting in these two updates to Part L and Part F, where in Part L, typically all new dwellings were going to achieve an A2 BER or better. We introduced the renewable energy ratio. We've already spoken about the EPC and CPC targets. There were various improvements to elemental backstop U values, and the upper limit of air permeability was reduced from 7 down to 5. The other important point to make is that all dwellings required an airtight test. There was no allowance anymore for this sampling that was allowed for under the old regulations. So in terms of Part F, yeah, we've already spoken, the air permeability index being down to 5 cubic meters per hour per meter squared. Dwellings that achieved an air permeability index of below 3 no longer could consider natural ventilation as a possible ventilation strategy for the dwelling. This is very difficult for a designer to try to achieve a value of between 3 and 5 when one is designing a building. So it's a safer option to consider mechanical ventilation, and that's really what we're trying to encourage, is some sort of mechanical ventilation system. To retrofit a mechanical ventilation system is not possible. It's not doable. In fact, we have horror stories being relayed to us where builders are going around cutting fabric to worsen their air tightness when they've deployed a natural ventilation strategy, which is just lunacy. So in Part F, they're introduced the new requirement for an independent, competent third party to carry out a validation of a ventilation system. So ventilated heat losses in housing consist of the undesigned leakage, and that's covered under the airtight test, as Emmanuel has alluded to. We've in excess actually of 70 registered airtight tester, so there's a good supply to the market there in terms of airtight testers. Then we have the design ventilation, and if it's a mechanical ventilation system, we supply air into what's known as, or what we term as, the habitable rooms, and we extract air from the wet rooms. So the Ventilation Validation Registration Scheme is in an effort to try to derive compliance in this space. So we've still have the capacity to accommodate natural ventilation, again, just between the 3 and the 5 air permeability index. Passive stack is another form of natural ventilation. Then we've got our mechanical ventilation, either centralized extract or mechanical supply and extract ventilations. There's also demand control ventilation systems I'll talk about that a little bit later on. So the scheme that we were tasked to develop by the department registers an individual as a competent person to go out and check and measure that a ventilation system as installed and designed and commissioned meets Part F requirements. To that end, we have our scheme document, and we draw upon ISEN 14134, the Department of Housing, Planning and Local Government's publication, Installation and Commissioning of Ventilation Systems, and the BSRIA Domestic Ventilation Systems, a guide to measure airflow. So ventilation systems need to be installed and designed to meet Part F in order to limit moisture and to limit the accumulation of harmful pollutants in the living space. And post the last 2 years, which is, by the way, it's great to be here to start off with after the last 2 years, but post-COVID, there couldn't be a greater focus on healthy indoor living spaces and air quality. So the ventilation validator, when he arrives on site, he will be presented with either a design for the ventilation system or a commissioning cert. The first job, he's not the designer, he's not responsible for the design, but he is responsible to run the ruler over is what he's been presented, broadly speaking, in line with Part F. And to that end, we'll see later on, he needs to maybe do a ventilation design for that house just to satisfy himself that what's presented is fit for purpose. But then he goes simply around, he measures the flows, the supplies, the extracts, or in the case of a naturally ventilated house, he measures the number of OPEs, wall vents, extract, intermittent extracts in wet rooms and the like. And being satisfied with what he's inspected, he issues a ventilation validation certificate. So during the development of the scheme, actually, everybody had an anemometer, which is the device used to measure flow rates. They had them calibrated, you know, they were either INAB or UCAS accredited calibration certs, but on the very first outing with 5, I think, would-be validators, we went into a dwelling and everybody read wildly different readings. And what came apparent to us is that despite the equipment being calibrated, they didn't know how to use the devices correctly. And this ranged from just configuring their measuring devices and using things called flow straighteners. So the typical devices you have available on the market to measure flow rates are either pressure compensating devices or anemometers with a vane anemometer. And if you've got a diffuser on a supply grill and it's causing a vortex or a swirl, it'll either overmeasure or undermeasure. So we had, as I said, 5 devices all measuring in wildly different readings. So with that, and in conjunction with Lindab and Chris Halligan, we developed a proficiency unit, which is housed down in WWETB, which is the box here, and it provides supply and extract on 2 different lines with an inline Unilink reader. And anybody who wants to apply as a validator needs to go down, take 20 readings and satisfy us that they can use their device and measure within a very low tolerance, a tolerance of plus or minus 10%. That's given great reassurance to us that anybody who's on the register is capable of performing the function of validating a ventilation system. So let's consider a house. So a typical 3-bedroom house, 122 square meters, 2.4 floor to ceiling. Now, I'm not going to go into all the detail on how one designs ventilation systems. If you want information on that, I suggest you go to the WWETB training course where they run through how one designs ventilation systems. But in general, it consists of, there's an occupancy rule and there's a square meter rule, and we work out and establish a general ventilation rate for a whole dwelling. We then redistribute that in the volume of the habitable rooms, and we balance that with the extract. So a system is supplying whatever 39 litres, needs to extract 39 litres to be balanced, and that's the general principle. So the general principle of the design of a mechanical ventilation system is that we supply to what's known as habitable rooms, we extract from the wet rooms, which I will go on to later, relays the importance of undercut indoors for there to be a satisfactory and a free-flowing and working ventilation system. There's a boost requirement then when wet rooms are being used, that the system can go into boost and extract moisture-laden air at a greater rate to, I suppose, on to the point that Richard was talking about, to regulate and limit humidity buildup, which in turn could give rise to surface condensation occurring and mold growth in an unhealthy living environment. So this is a sample certificate that a validator but you people would be looking for as part of the BCAR submission. So in simple terms, it's just the first thing to note is the validator certificate number. You can check whether that person is actually a registered validator on the NSAI website. You can contact them. Their email is there to do that and inquire even, did you do this validation? So the presented design, there's supply rates, trickle supply rates, they're measured and they're checked to see that the as measured met the as provided design. The boost rates are checked, the extract rates are checked, and subject to all things being in line with the presented design, a pass certificate is issued. And that's what we want to see. In addition to the airtight test in the BCAR pack, we want to see that these validation certificates are checked. The point I made earlier on the validator entering into the dwelling and establishing first and foremost that as what was presented to him was fit for purpose is covered under this section here. Was the design as presented to them, in their opinion, meeting the minimum requirements of Part F? And if it doesn't, they have an option there to select this. And this is saying that the presented design, in their opinion, did not meet the requirements of Part F, and further evidence should be sought from the design certifier or the designer of the system as to how compliance was formed. So it was important, and I think the department wanted to ensure that it was not removing the obligation on designers of ventilation systems that validators would just come in and pick up the tab and be responsible, the responsible party. They're not the responsible party for the design, but they are responsible for offering an opinion or a comment on whether the design was fit for purpose. So demand control ventilation, I said earlier, is a possible option. Demand control ventilation systems operate on the basis that they ramp up in times of spikes in humidity. Humidity generally, so when there are lots of occupants in the room, they have a moisture sensitive strip in their supply grills or their extract grills. These strips will expand and ventilation rates will increase in times of high occupancy. Demand control systems that wish to operate sub minimum ventilation rates of technical guidance document Part F will require an agreement certificate. So the agreement certificate assesses the suitability of the system to perform sub Part F levels. And there is a process agreed with NSAI agreement on how they can check those systems by measuring pressure differential. Any other system, demand control system that's out there that has been installed that does not have an agreement certificate, in our opinion, at their minimum setting, should achieve the minimum requirements of Part F. So what to check? We've said it before, we'll just go through it again. I'm going to repeat it again. Is first, airtight test report. Where is it? What's the value? Is it below 5? If yes. If it's below 3, only mechanical ventilation strategy is suitable for the dwelling. Natural ventilation is not satisfactory. And the final part of the jigsaw, is there a validation ventilation cert, a validation ventilation certificate contained within the BCAR pack that demonstrates that the system has been checked by an independent third party and that it passes the checking. And that's effectively my presentation. So.